We're Garrett and Paul Sutherland Santo. As designers, we believe that our work has a responsibility to help bring our built environment more in sync with our natural one.
Our project Biocraft combines digital technology with plant-based polymer to develop an array of material that actively improves our health and the environment. Living in downtown Los Angeles, the most polluted city in the US, finding a way to get clean air has always been a struggle, particularly with the lack of space for bulky appliances like air purifiers. This is Carbon Stool. It's lightweight, durable, and made entirely from plant-based materials. These are biotiles. They're modular, customizable, and biodegradable. And unlike other household objects, Carbon Stool and biotiles are cleaning the air right now.
Both of these products are applications of Biocraft, a collection of new material that improves our air quality and our health. Our project pairs biopolymer gel and digital processing to produce fully custom material, highly tailored to fit specific applications, allowing the material to be designed with the same care as the product it's meant for. This is possible through the use of software we wrote to precisely 3D print Biocraft gels. We can achieve virtually any pattern, and natural pigments allow for vibrant colors. The result is a library of fully custom materials from the same base gels, varying in qualities like texture, elasticity, opacity, and patterning. Biocraft material is derived from plant matter and is biodegradable and compostable. This means that these materials break down naturally and easily without the excess energy or resources required to dispose of synthetics or even common bioplastics. This material is unique for its ability to dynamically interact with our surroundings and with us. Carbon sequestration occurs within the biopolymer gel, where intermolecular attraction magnetically binds carbon dioxide and VOCs, scrubbing the air of these harmful greenhouse gases. This means that anything made of Biocraft material can clean the air. The life cycle of Biocraft's carbon adsorbing material is designed to mimic the natural carbon cycle of our planet. Once it's saturated, the material is composted, and the CO2 that has been collected from the air is transferred into the soil, where it's stored naturally, improving soil quality and health. Using a similar process, vitamins and nutrients can be mixed into Biocraft material, allowing them to be released when biopolymer is exposed to moisture or as it breaks down. Anything made from Biocraft material can provide nutrients. Another benefit of our material is its usefulness in many applications. During our research, we tested numerous variations of the Biocraft polymer and developed a library of materials with a variety of mechanical properties. This selection demonstrates the range of characteristics that can be achieved with minor customizations to the biogel, varying from highly flexible on the left to very rigid on the right. Expanding this structural grid and overlaying it with performative properties, including most carbon sequestering at the top and most nutrient releasing at the bottom, you can see a cross-section of the many variations of Biocraft material we've developed to date. This means that qualities like transparency and surface texture are capable of being fully designed, allowing Biocraft to balance aesthetics and functionality.
Our case studies are fully executed examples of using the materials from our library to produce fully functional carbon sequestering products. They were built from 3 base polymer types. The cores of both were made from aggregate pulp for lightweight and durability, and both are laminated with biopolymer gel. The stool seat cushion is 3D printed from biopolymer foam. Its design was aided by the use of an artificial intelligence neural net. We trained the AI network on textures and nature with high surface area. We used the network to produce thousands of cushion designs by having it generate new patterns guided by seat pressure maps. The result are 3D designs with high surface area for optimal carbon capture, balanced with comfortability. You can see hundreds of these 3D designs strung together here in this animation. We chose a seat design variation we preferred and used our software to 3D print it with Biocraft foam. While our stool was designed to replace furniture with a carbon sequestering analog, biotiles utilize empty wall space by converting it into a natural carbon filter. Biotiles were molded into 3 tile types of varying depths that are easily biodegraded and composted, and intended to be swapped out with new tiles when they become carbon saturated. Both case studies demonstrate our intention for Biocraft to balance the natural with the digital to allow for highly tailored products. We developed Biocraft to support our planet's natural carbon cycle, and there are few better ways of doing that than assisting reforestation efforts. Tree pods are a way for us to help our environment outside of our apartment walls. They're a Biocraft replacement for traditional growing tubes relied on by forestry services to efficiently grow, plant, and protect saplings. Our material improves on these existing tubes by being biodegradable, reducing the labor required to recollect the tubes of grown trees, and by releasing nutrients into agriculturally depleted soils where reforestation is most often needed. Tree pods utilize 3D printing for mass production and are folded into shape at the nursery, where Biocraft's carbon sequestering material captures carbon until the sapling has grown large enough to do that itself.
Like all potential applications of Biocraft, our case studies are effective ways to tackle excess CO2 and greenhouse gases only if they're deployed on a mass scale. Since the US has failed to respond to climate change, and even withdrawn from the Paris Climate Accord, we believe these challenges are now up to grassroots movements and individuals. We also believe that design can be a conduit to enact change. We developed Biocraft to clean the air, restore the natural carbon cycle, and supplement synthetic and petroleum-based materials, which have led to unhealthy levels of waste in our oceans and even our bodies. Biocraft is based on the belief that materials should do more, and now they can.